Hi, this is David Quatello at Siemens. In today's BrainShark video, we will be covering the basics of electricity. Throughout this course, there will be points where you have check-ins, we'll ask you some review questions, and then at the very end, we will have a final exam. So let's get started. Let's go ahead and go over the course topics. In Chapter 1, we'll be discussing direct current. And by that we mean direct current basics, DC circuits, and magnetism. In Chapter 2, we'll be discussing alternating current. So alternating current basics, inductance and capacitance, AC circuits and transformers, and then lastly we'll have a final exam. If you do not have a basic understanding of electricity, complete this course before starting any other Quick Step online courses. Upon completion of this course, you will be able to explain the difference between conductors and insulators, use Ohm's law to calculate current, voltage, and resistance, calculate equivalent resistance for series, parallel, or series parallel circuits, calculate voltage drop across a resistor, calculate power given other basic values, identify factors that determine the strength and polarity of a current carrying coil's magnetic field, determine peak, instantaneous, and effective values of an AC sine wave, define inductive reactance, capacitive reactance, and impedance, calculate total impedance of a simple AC circuit, explain the difference between real power and apparent power in an AC circuit, and finally, determine how a transformer turns ratio affects secondary voltage and current. Chapter 1, Direct Current. This chapter covers the following topics: direct current basics, DC circuits, and magnetism. All matter is composed atoms. Atoms have a nucleus with electrons moving around it. The nucleus is composed of protons and neutrons. In their neutral state, atoms have an equal number of electrons and protons. Electrons have a negative charge. Protons have a positive charge. Neutrons are neutral. The negative charge of the electrons is balanced by the positive charge of the protons. Electrons are bound in their orbit by their attraction to protons. Electrons in the outer band can become free of their orbit by the application of some external force, such as movement through a magnetic field, friction, or chemical action. These are referred to as free electrons. A free electron leaves a void which can be filled by an electron forced out of orbit from another atom. As free electrons move from one atom to the next, an electron flow is produced. This is the basis of electricity. An electric current is produced when the free electrons move from one atom to the next. Materials that permit many electrons to move freely are called conductors. Copper, gold, silver, and aluminum are examples of materials that are good conductors. Copper is widely used as a conductor because it is one of the best conductors and is relatively inexpensive. Materials that allow few free electrons are called insulators. Materials such as plastic, rubber, glass, mica, and ceramic are examples of materials that are good insulators. An electrical cable is one example of how conductors and insulators are used together. Electrons flow along a copper conductor in a circuit, and the insulator around the outside of the copper conductor keeps electrons in the conductor. Semiconductor materials such as silicon can be used to manufacture devices that have characteristics of both conductors and insulators.